Sorry guys, just messing around with a couple of things, but had some tech difficulties, but we should be okay. Um, just double checking that you guys can actually hear. Cool. So what we've got today is I've basically got some of these questions from the last time I ran the tutorial, and yeah, so some of these questions I'm still kind of going through the Facebook and Instagram at the moment, and there's just like tons of questions that I need to go, and I don't know if I can get to all of them. But what we'll do is these are the questions that we're going to go through today. So this is a differentiation one, a couple of differentiation ones, and whenever this question loads up, yeah, so we'll start with this differentiation one. All right, because I think this is from 2017 paper. Let me just check real quickly. I'm sure it was from 2017. Maybe not. Well, whoever gave me this question, they gave me the wrong paper. Let me try 20. Better not be 2018 because I've actually done the 2018 paper already. Oh, is it? If it's from 2018, I'm actually not going to do this question because the video is already out there for it. Yeah, so there's a couple of questions from 2018 in this paper that I can see right now. So what I'm going to do is let me just start writing this down. So sorry, whoever sent me this particular question. Check out the 2018 paper. There is also this question. Is that from 28? Yep, that's also from 2018. So check out the 2018 paper. So guys, like some of the NCEA exams, I've done 2018 and 2019 already as videos. So it's just no, yeah, we're going to be wasting a hell of a lot of time if we're going to be going through questions. Yeah, so C is from 2018 as well. So whoever sent me that question, I can't remember who it was, have a look at the 2018 differentiation paper. The video is already there for it. Okay, so in saying that, let's actually get through this particular question here. So this one was a locus question. I can't remember where this question actually came from. Is this from 2018 algebra? Jeez. Really, guys? Have I done this one as well? Surprising that you guys actually remember these questions. Cartesian plane. No, it doesn't look like it's 2018 paper because I don't remember doing this particular question. Yeah, no. This question I don't think I've actually done before. Okay. Maybe. I don't know, man. I forgot. Yes, Andrew, I am. So do you guys want me to do this question? And I think we should kind of do it real quickly, just as a quick refresher. Oh, really? Oh, man. Jeez. I've done all of these questions then. Okay, so which one was it? Did you guys say locus? Okay, so that would be the mathemic series. So whoever sent me this, check out the mathemic level 3. I think it's the last video in that series for locus. Okay, let's go to the next one then. I think this one actually was 2018. Now I just had a look at that. So check out 2018 differentiation paper. That should be there. Okay, let's go this one. Come on. So far I've actually picked up like all these questions that have been done before. Have we done this question? Uh, 2019 integration, Andrew. I've already done it. That paper is there. Okay, so we haven't actually done this question. All right, so let's try this question. What we have got here is a differentiation question. Yeah, I haven't actually got the D&D stuff, guys, so I wouldn't have a clue. Okay, so that's fine. I've got somebody that doesn't know what to do, so I will try and explain this. Remember that what you've got here is a function. Basically, this function is, we've actually got two kind of unknowns here. So we've got f of x is equal to, so what do we got? F of x is equal to x over ax plus b squared. Now, what we also know is f dash of x. F dash of x is going to equal to 0, and also f dash double dash of x is also equal to 0. Okay, Lucas, all right, let's try this question. Yeah, we can actually bring that up, but first there's a few things that we actually need to do first. So here's what we're going to do. We're going to have to differentiate this function. To differentiate, oh wow, I can see what you guys mean by Lucas. This is going to be one nasty question, but that's all right. So because we have point of inflection at 12 1/3, what we can actually say is we're going to actually do f dash of x first. So to do f dash of x, we are going to use the quotient rule. So that means we're going to put this as u equals to x, v is equal to ax plus b squared. So u dash is equal to 1 and v dash is equal to 2ax plus b multiplied by a. Is it actually quite a long one, Lucas? Okay, let's just keep going. So because it's quotient rule, what I'm going to do is I've got u dash v minus uv dash equals v squared. So I'm going to get u dash, which is 1, v is ax plus b squared, minus x multiplied by, yeah, I can see what he means by, you're going to get 2a ax plus b, and the whole thing is now divided by ax plus b squared squared. So now we know that the gradient is equal to 0. So because it's equal to 0, we can actually put this ax plus b squared minus x times 2a times ax plus b as equal to 0. Because when we take the denominator to the opposite side, it ends up being 0, so we don't have to worry about it. So we can actually say f dash of x is equal to 0 for turning point. So that's why I did this. So rearrange this, and I'm going to get x times 2a times ax plus b equals ax plus b squared. Now I've got 2ax equals ax plus b over, ax plus b, like that. Yeah, Lucas, so I kind of mentioned that at the top there, because the gradient is also going to equal to 0, right? And the double differentiation is going to equal to 0. Anyway, let's kind of keep carrying on here. So what happens is we're going to actually end up canceling we're going to end up cancelling one of the ax plus b, so we're going to get 2ax equals to ax plus b. So when we do 2ax, what do we got? 2ax minus ax equals to b. So in this case, we're going to get ax is equal to b, and so we can really say that x is equal to b over a. So what does that tell us? So the turning point happens when x is equal to b over a. All right. I'm just trying to figure out how I can kind of mess around with this. I guess we can try and do f double dash. And f double dash is going to be ending up has a point of inflection at 12 1/3. I'm just wondering whether I could actually do this. See, I want to actually do this. I want to actually figure out what a and b is. So no, I can't do that yet, because I could have done this, because I know that f of 12 equals to 1/3. So I can actually say 1/3 is equal to 12 over a times, so 12a plus b squared, something like that. So I could rearrange this, and I could have got 12a plus b squared equals to 36. And of course, that gives me another equation to kind of work with. Use f of x for the values. I'm not understanding your question there. How to write an equation for a and b. Anyway, look, let's just keep going. Let's just see what happens when we do f double dash, because f dash of x now, even though it's super ugly, it's ax plus b squared minus 2ax multiplied by ax plus b, and that whole thing is divided by ax plus b to the power of 4. So what I'm going to do is, in the numerator, I'm going to try and expand and simplify before even differentiating it. So I'm going to get a squared x squared plus 2abx plus b squared minus, and inside here I'm going to get 2a squared x plus 2abx, and that all of that is divided by ax plus b to the power of 4. Yep, that's another, but then differentiating it is going to make it a little bit more complicated, right? Wouldn't it? Because then I would have like, on one side I'd have like ax plus b squared, on the other one I'd have ax plus b to the power of 3. So I don't know, man. Let me just try this one, see what happens. So I've got a squared x squared plus 2abx plus b squared minus 2a squared x minus 2abx over ax plus b to the power of 4. So still haven't done any kind of differentiation. This is going to become b squared minus a squared x over ax plus b to the power of 4. I think I'm going to get somewhere here. So now I'm going to go u is equal to b squared minus a squared x. So u dash is equal to negative a squared, and v is equal to ax plus b to the power of 4, and v dash is equal to 4 times ax plus b to the power of 3 times a. Where have I missed that? Oh, yep, yeah, that's all right. It still is going to cancel out, so if that's the case, then I'm going to get minus 2a squared x. Yeah, good point. Okay, so if I double differentiate, I am going to get, yeah, you're right, this is a super ugly question. Curse the child that sent me this question. Ax plus b to the power of 4 minus b squared minus a squared x squared times 4a ax plus b to the power of 3, and that whole thing is now divided by ax plus b to the power of 8. Yeah, it is a lot of working actually. So now we're going to put f double dash equals to 0, which means 0 is equal to negative 2a squared x, ax plus b 4 minus b squared minus a squared x squared. God, jeez, this is a long question. Maybe we should have a rule that we just don't send like ridiculously long questions. Nah, Ivy, I've not seen it, but it's like, if you do get a question like that, I don't think they're gonna make you do this much amount of working. This is just ridiculous amount of working. So I don't even know, I'm sure I'm gonna get this wrong somewhere. I just get this really sick feeling. Ax plus b to the power of 4 equals minus b squared minus a squared x squared times 4a times ax plus b to the power of 3. So what I can do is get rid of this, get rid of just that as 1. So I've got 2a squared x, ax plus b equals negative 4a times b squared minus a squared x squared. All right, so what do we have here? We've got 2a cubed x squared plus 2a squared bx, yeah, equals negative 4ab squared plus 4a squared x squared. Oh no, that's a cubed, sorry. Whew, wow. Thank you to the person that actually sent me this. We're still going to keep going, right? Because, I mean, like, what do we've got? We've got 4ab squared plus 2a squared bx equals, what have I got here on this side? On this side, I've got 4a cubed x squared minus 2a cubed x squared. So this gives me 2a cubed x squared. And here, what have I done so far? I've got something to help me, right? Come on. So x is equal to b over a. So because x is equal to b over a, I could actually say 4ab squared plus 2a squared b, b times a, and what is that going to give me? 4ab squared plus 2ab squared equals 2a cubed x squared. So this becomes 6ab squared. We're kind of getting along nicely here. Equals to 2a cubed x squared. What else can I do here? What else could we do? What else could we do? How long have you spent on this question, Matt? 20 minutes? Where have I made the mistake, or what am I missing? We're pretty close. Because we just want to prove that it's at 12 1/3, right? So if we actually say that we just have to show that f double dash of x is 12. So if I put that as 12, at 12, it should equal to 0. So I just need to prove yeah, we find A and B, and unless I'm like messed it up completely somewhere, it is possible, because all I'm getting is x squared is equal to 6ab squared over 2a cubed, which is 3b squared over a squared equals x squared. But I do know x is equal to b over a, but that doesn't really give me anything. It means I've made a mistake somewhere. So, yeah, whoever sent me this question, unless you could sub in x equals to 12. Yeah, but that's just going to give me 3b squared over a squared equals 144. And then b squared over a squared equals 144 over 3, which is, I don't know, my head is not working, 48. But apart from that, all I got is b squared over a squared equals 48, and b over a equals to x. That's what I have. I should have listened to you, Lucas, when you actually said this was going to be a long question. I guess the one other thing that I have is like something like this. Because I've got 12a plus b squared equals to 36. I wonder if I can do this. If I expand this, I'm going to get 144a squared plus 24ab plus b squared equals to 36. And then I could potentially say that b squared is equal to 48a squared. I'm probably going around and round in this. And what have I got? So then I can say 144 take away 48. That's going to be 96a squared plus 24ab equals 36. If x is meant to be BA. Oh man. Yeah. You know what? I think I'm going to take a break with this question, guys. I actually want to come back to this question later on. It just threw me off completely. Yeah, but Lucas, it actually makes it plus or minus 6. Because I was trying to get something where I could maybe prove that x is equal to 12 or, yeah, but I think I already substituted x equals to 12 somewhere. So now let me have a look at it later, because sometimes it's just like in the exam, you know, you deal with a question and you kind of go halfway through the question and then you go, man, nothing's working. You leave a break and then you come back to it after that, and hopefully we can actually come back to it. So let's go to something different, and what I'm going to do is I'm going to leave this question with you guys, and yeah, maybe there's like, usually what happens is like the problem with these big calculus questions is that, you know, you tend to think in one way, and then they come out and show like a little trick which you never thought about doing, and that's what's so frustrating about these papers. But anyway, we're going to try this question here just to kind of go back to some simple merit questions, and we'll come back to it again. Just have a go at this, guys, and just going to get me some more water. I'll be right back. me see. How are we going for this one here? Now I've got quite a few questions that's actually popped up. I just haven't had a chance to actually put them all together, but I will. Nah, Saj Breather, I'm sure I made a mistake somewhere. It's like usually ends up being like a really stupid mistake. And I think that's why, yeah, I want to go back to that question. I'm sure there's like a simpler way to do it. But anyway, look, let's actually go through this question. So this question, it actually says prove that the roots of this equation are always real. So all you really have to do is just put down b squared minus 4ac, find out what b squared minus 4ac is, and then try and prove that that equation that you get is always going to be above 0. All right, so here, because you are saying that it's always going to be real, we're going to put that as b squared minus 4ac is greater than 0. And so what we have got here is 2c plus 1 squared minus 4 times 3 times negative c plus 3. And that has to be greater than 0. All right, so here we're going to get 2c plus 1 squared plus 12 times c plus 3 is greater than 0. So we've got 4c squared plus 4c plus 1 plus 12c plus 36 greater than 0. Putting it all together, we are going to get 4c squared plus 16c plus 37. Because it actually says the roots, I would say greater than 0. Yeah. So at this point, what you need to do is you got to complete the square. All right. So for completing the square, we can actually do something like this. Because this is 4c squared, we could just kind of rewrite that as 2c squared. So it's going to be 2c and 4. So when we do 2c and 4, what we're going to get is 4c squared plus 8c plus 6, not 8c, that's going to be 16c plus 16. So what we're going to do is we're going to split this up as 4c squared plus 16c plus 16 plus 21, and that has to be greater than 0. And what that means is we're going to get 2c plus 4 squared plus 21 is greater than 0. And at this point, you have to actually kind of say that because you've got a squared number and you're going to add 21 to it, it doesn't matter what c is, you're always going to get two values. Thanks, Eva. I'll have a quick look at it, man. Yeah, I'm losing my voice completely. This is all from Sunday. But just annoyed at that question because we did do quite a bit of work for it. And I can just feel like it's just going to be like something really, really silly that we've done. Where did I make my mistake? All right, actually, we'll come back to this question. Are you guys actually happy with this question? Can we actually move on? So you guys happy with question D? Okay, cool. So let me pick up some, I just need to double check because there was like a whole lot of questions to me sent. And it's like all over the place at the moment. 11, what do we got? Okay, that's all right. Okay, so here we go. This is 20. 2013 paper. All right, so here's an interesting question. Why can't I open it? Oh, this just sucks. I can actually see the question, but I cannot seem to open it. Why? Open image in a new tab. Oh yeah, here we go. Where are we going to put it? Just give it a sec, guys. It will take a little bit of time to sync up, but we should see it very shortly. So the next question, it tends to be another differentiation question. It will pop up, and we can actually go through that question, all right? Yeah, TS, so basically just saying that c plus 2 squared is positive for any value of c. Therefore, we can just kind of say that that number will always be positive, and because it's always positive, you're going to get that value is going to have two roots. All right, so here we go. Try this question here. We want to try and find the maximum value of this particular function. And I'm going to go back to that other question. I will not be defeated by that question. Where did you make a mistake? Thinking b minus x. How the hell is that possible? How? Two x plus b. B minus ax. Huh. You cheeky buggers. 2a squared minus 4ab. Minus 2ax. Okay. I think I can finally see where my mistake is. We can try it again later. All right. How far are we in this one? Yeah, half cup of rice. I saw that as well. I think I did make a mistake somewhere there. But anyway, let's go through this question here. So with this question, what we've got is just differentiate it and then find out what the max is. And I guess the common mistake people kind of end up making is that they don't actually recognize that we're dealing with a product rule right there. So we're going to get f of x, but that 30x, we want to do that separately. So what we're going to do is you're going to put down u equals negative 30x and v equals ln of 2x. So u dash equals minus 30 and v dash equals 1 over 2x times 2, or you're just going to get 1 over x. So once we do that, we're going to do f dash of x. So f dash of x is equal to 50x when you differentiate it as 50 minus, and this is this part is actually important. Now it depends where you put the minus, right? Like, so because I differentiated it as minus 30x, I can actually put it as a plus and then put it as u dash v plus uv dash. And so when I do this, I'm going to get 50 plus negative 30 times ln of 2x plus negative 30x times 1 over x. So when I actually do this, I'm going to get 50 minus 30 ln of 2x, and my 2x's cancel out and I'm left with minus 30. So I've got 20 minus 30 ln of 2x, and this is now equal to 0. So rearranging it, we're going to get negative 20 equals negative 30 ln of 2x, or ln of 2x equals negative 20 divided by negative 30. So basically we can say that 2x is, ln of 2x is equal to 2/3, and 2x is equal to e to the power of 2/3, which means x is equal to e to the power of 2/3 divided by 2. So is that all right with that question? All right, let's go pick up another question from, where did I, so summer here. That last one looks fun. We've actually done quite a few differentiation questions. It's almost like you guys don't like integration. .974. Let me have a look at the answer. It is 0.974. I guess 973, 974. You're good to go. All right. This question is not fun. What is this question? This is a level 2 question, I think. Yeah, it's a level 2 question. Okay. Is anybody sending me any other questions anywhere else? Because these all seem like level 1 and 2 questions, unless I missed one of your questions. Yeah, send it to me, TS. Let's work on it. Yes. Tomorrow. Where are you sending it, TS? Yeah, friction, send it, man. They want to find the points of intersection and equate a cos squared x. I'm thinking it should be cos squared x. Oh, no, it's all good, all good, all good. Yahweh, nah, man, like, that just drives me nuts. Scholarship. All right, shot TS. I'll pick it up. Jeez, you guys picked some real nice questions to kill me today with. All right, let's try this one. Are you sure I haven't done this one? This looks very familiar. Where is this question from, TS? I have a feeling that I've suffered this question before. Can you just drop the schedule, what the answer actually looks like as well, please? Just so that we don't go around in circles. Sorry guys, that question should be popping up shortly. It just takes a bit of time to sync up. It is a algebra excellence question. If alpha, beta, y are the roots of this, then express the equation whose roots are 1 over alpha. Jeez. Yep. Why are you taking so long to sync? Come on. Oh yeah, Angie. Man, those ones, I need to actually go through it again on my own first to try and explain it to you guys without wasting your time. I had a look at those questions. Beautiful questions, but I just haven't had the time to kind of do it in a way where I can explain it to you guys without driving you nuts. So it is actually on my top of my list there. Why is this not syncing, man? Come on. I don't think it here we go, it's coming. Okay, here we go. Try this one here, guys. So this looks like an excellence question, for sure. But it is, God, it's another annoying question as hell. It's just like an expanding question, that's all. It's actually not too bad. But yeah, it's just like this really annoying looking expansion question. So, shall we actually start working on this? Yeah, pretty much. Omega, that's basically it's what we're talking about. No, this one's actually not too bad, actually. Because all you have is that you just have to write down this as, because of 3 roots, right? So you got z minus alpha. And I remember doing this question, and I hated using alpha, beta, and gamma. So I'm actually going to change the letters to alpha equals to P, beta equals to Q, and gamma equals to R. All right? Just because I hated writing with those symbols. So yeah, I hate those roots. So that's why I just put it as PQR. All right, so then I get Z minus P times Z minus Q times Z minus R. Okay, and because they're all roots of these questions, then you could actually just put this equal to Z cubed plus AZ squared plus BZ plus C. So what you've got to do is, yeah, this is an excellence question, Angie. if I remember. Then what you can do is you need to expand the brackets. So doing the first brackets, you're going to get z squared minus, what is it, pz, qz, oh god, this is another ugly question, isn't it? Qz minus pz plus pq, and then we've got to multiply that by z minus r. So then we're going to get z cubed minus r z squared minus q z squared minus qrz minus pz squared, no, I messed up, plus qrz minus pz squared, and then plus pzr plus pqz minus pqr. So once we get that, now what we can actually say is, well, we've got z cubed here, so that's kind of matching up nicely, so we don't actually have to worry about it. The next thing is the coefficient, which is c by itself. So we can, this part right here is going to equal to c. Because TS, it's because it's the you're looking at matching the coefficients. So if you look at coefficient of z is, like right now it's bz, which means you're gonna have to take all the ones with z by itself, and you're going to have to put it equal to the coefficient of z. And then you take all the coefficients of z squared. So az squared will basically be this, this, and this. And then finally your z cubed is already kind of sorted out, so we don't actually have to worry about it. So at this point we can actually say minus, let me just do that. So we can actually say minus rz squared minus qz squared minus pz squared equals to az squared, which means a is equal to minus r minus q minus p. And I hope I did that right, because I get a feeling I made a mistake somewhere. Don't know why, I just get this feeling. Nope, that's all fine. Then we've got bz is like qrz plus prz plus pqz equals to bz, which means b is equal to qr plus pr plus pq. And we finally have c, so c is just equal to minus pqr. All right, so next part after that is, now we've actually got to put the roots in. So the roots one was like basically saying it was 1 over p, 1 over q, and 1 over r. So what we're going to do is we literally have to write this as z minus 1 over p times z minus 1 over q times z minus 1 over r. Now, guys, I am gonna kind of like this question. It's like basically it's just like expanding and then resubstituting it again. So all you got to do is which part are you stuck at, TS? So the reason c is equal to minus pqr is because c doesn't actually have a z attached to it. And if you look at the left-hand side, pqr is the only thing that doesn't actually have z attached to it. That's why I've highlighted it in light blue. Yeah, it's a different concept, Lucas, but yeah. Okay, so now we've got our second equation, so which means we actually need to expand this second equation out. So we're going to follow pretty much the same procedures as before. So we've got z squared minus z over q minus z over p plus 1 over pq multiplied by z minus 1 over r. So we're going to expand this brackets out again. So we're going to get z cubed minus z squared over r minus z squared over q, and then we've got plus z over qr. This part I got to be careful with, minus z squared over p plus z over pr plus z over pq minus 1 over pqr. Yeah, this is complex numbers, man. Oh, sorry, I missed your question completely, Ivy. Apologies. Thanks, guys, for picking it up. Yeah, so now that we've got all of this right, what we then do is we do the same thing as what we did before. So we've got to actually collect all the like terms, right? So we're going to go z cubed, and here we've got minus z squared over p minus z squared over q minus z squared over r, and then here we've got plus z over pr plus z over pq plus z over qr minus 1 over pqr. So at this point, what you have to do is you literally have to kind of collect all the like terms. And well, not like terms, but I mean, what we can do is we can rewrite it like this: z cubed equals minus, and in this bracket we're going to have 1 over p plus 1 over q plus 1 over r z squared plus 1 over pr plus 1 over pq plus 1 over qr times z minus 1 over pqr. I hope that was okay there, what I just did. Nah. This is just like a proof question, right? The last bit that we have to do is like just combine them all as fractions. So we're going to get z cubed minus, in the top there, we're going to get qr plus pr plus pq divided by pqr z squared. And this is where things actually start getting a little bit interesting, because we're combining those fractions. All we have to do is just match with our ABCs from previous cases. So in the top line here, we've already got that. So this is going to be, so the denominator is going to be that. So we're going to end up with Q plus R plus P over PQR minus 1 over PQR. And at this point, we can just start substituting what we found from this box right here. So because we can actually say that negative PQR equals to C, this part here becomes C, and then we've got negative R minus Q minus P. We can actually replace A there, and then finally QR, PR, PQ, we can actually replace it there. So that's literally how you get rid of the A, all the PQR, and replace it with ABC. Now, this is a freaking annoying question, but it works. So all you got to do at that point is like they just have to you just have to substitute the values in. Yeah, nah, man, I'm pretty like the last 3 days I've just been like getting up every morning at 5 just to make videos here and there and then do schoolwork as well. So it's been a bit full on. All right, TS, that question is done. Oh, hang on, we've got another question there. Oh, that's actually nice. Can I just do like a simple one for a change? Just so that my head doesn't have to think so much. That's the problem with calculus excellence questions. It's like it really pushes you hard. Have you guys ever seen this type of question? Find A and B such that yeah, this one. Solve for A and B. Samuel, I'm sorry, I don't actually end up doing probability. It's just I don't know. It's somebody else's territory, man. Sorry, Sam. Yeah, no, I'm not doing probability or stats anytime soon, man. All right, so this question here that we've got, question C. Let me just give me 1 second. I just need to jump in. I'm supposed to be attending a call right now, which I haven't. Meeting in CC ended 26 seconds. What? Oh. Where the hell do I join the call? Okay, that's all right. My exam is next Thursday. All right, so how do we go with this question? Look, all you got to do with this question is simply just cross multiply and rearrange the numerator so that it equals to 2. All right, so what do I mean by that? What we're going to do is in here, this part here we can actually cross multiply, and what we're going to end up with is a times x minus 3 plus b times x plus 1. And at this point, because we cross multiplied, the denominator is going to be x plus 1, x minus 3, and this is now equal to 2 over x plus 1, x minus 3. So at this point, we really don't need to worry about the two denominators. They just cancel out each other. So all we left over with is just 2 equals a times x minus 3 plus b times x plus 1. So at this point, we're going to expand the brackets. We're going to get ax minus 3a plus bx plus b. So this is very similar to when we used to match real and imaginary. So if you think about this, I'm just going to rewrite this 2 as 2 plus 0x. So what I'm essentially saying is that negative 3a plus b is equal to 2, while bx plus ax equals to 0x. So in other words, I can actually say that ax plus bx is equal to 0x. Therefore, I can actually say that ax equals to minus bx and a is equal to minus b. So my next thing is negative 3a plus b is equal to 2. So negative 3 times negative b plus b equals to 2. I've got positive 3b plus b equals to 2. Therefore, 4b is equal to 2 and b is equal to a half. Therefore, a equals negative half. Okay, hang on. Sorry, I'm just kind of like listening to another call and teaching you guys at the same time. I can't actually do that. It's actually too much. So basically, all I've done is like how you meant to know real equals imaginary. Well, yes, in this case, it's got nothing to do with real and imaginary. All I know is I'm using that concept of real and imaginary here. If you think about it, there is actually no x numbers on the right-hand side, and there's only the real number, which is 2 on the left-hand side. But it's just matching the real numbers and the x's. So instead of it being I, it's just x that you're dealing with. All right. Show conversation. All right. Any calc exam, mate, Lucas? I've got no idea, man. Like honestly, it's I've not even thought about it. Like, because to be honest, I'm not teaching NCEA 1, 2, 3, so I am actually not stressed about it. So I can just kind of teach when I can, and so not really stress about the questions. Yeah, kind of TS. Like this one, you've got like one equation and you've got two unknowns. And so in this question, you can easily kind of just match things up. What do you want me to explain, Lucas? Oh, so you're talking about cos squared x equals cos 2x. Is that what you're talking about? So the reason I know this is true is because so remember that cos 2a, cos 2x, can be written as 2 cos squared x minus 1. So then if you rearrange it, you're going to get 1 is equal to 2 cos squared x minus cos squared x. So which means cos squared x equals to 1, cos x equals to 1. But then, how do you get pi? I'm actually getting cos x equals to 1 is x. Cos x equals to plus or minus 1, sorry. Which means x is equal to 0, pi, and 2 pi. Where did I miss it? Now, this was from the double angle identity. How would you integrate cos to the power of 4x? Yeah, so Bambi, in this case, when you actually take cos squared x equals to 1, when you take cos x is equal to square root of 1, which is equal to plus or minus 1, so that's how you end up with three answers. Because when x is equal to 0, cos x is equal to positive 1. When x equals to pi, cos x equals negative 1. And then when it's 2 pi, it's equal to positive 1. So you actually have three answers for this particular question. Cos to the power of 4x. Cos to the power of 4x. You could do it as, did you say differentiate or integrate? Well, you could do it like this, because cos 4x could be written as cos squared x times cos squared x. And then you can rewrite this as, how would you write this as? Nah, substitution won't work. Hang on, let me just double check. Trig reduction formula. I've not seen that before. Wow. Yeah, no, I've not seen that formula that being used at level 3 calc. If you want to have a look at it. Check out that. Okay. I need to actually go back. No, I need to go back and have a look at it, man. All right, guys. Look, I am basically gonna call it because like I'm losing my voice and I can't stay awake. So I will have a look at that question again, and I'll actually get back to you guys. I think I'm seeing you guys again on Sunday. Is that correct? Am I seeing you Sunday? Where are we at? Where are we at? Yep. No, I'm not seeing you Sunday. I'm seeing you guys back on Tuesday next week. Yeah, I've got all these other tutorials and I just, yeah, need a little break. I'll try to stay healthy because it's just like I just need some sleep for a couple of days. Actually, Lucas, I think it's just nice helping people. It's always something that I like to do, and it's something I can do now. But I mean, I wish I could actually do more right now, but I'm like struggling to stay awake, and my voice is completely cracked. So yeah, I need to take a pass. But we'll come back on Tuesday, But if you are sending me questions, guys, just so that we didn't actually end up wasting half an hour today, if you do have the answers, just flick it to me, because usually when I see the answers, I can see a different way of actually explaining it to you guys, because the way my head actually thinks when I'm looking at a question, it might not make sense to you. So like, there was a couple of questions when I just kind of like whizzed past straight away without explaining, because I just needed to get the question out done. So yeah, but apart from that, I think there's a little study group that's being created right there. So good luck with it. And hey Debo, what's up, man? Yeah, but that's basically it from me this session, guys. And I will catch you guys on Tuesday. But like I said, send me questions and the answers so that we can actually get through them quick next time. Yeah, no problems, guys. And I will see you guys Tuesday. I got to jump on this other call now. I don't want to, but I have no choice. Cool. See you later, folks.